This fjord is 1,300 meters deep, deep enough to completely swallow the English Channel with room to spare. And right now, in the year 2025, there's absolutely nothing crossing it, no bridge, no tunnel, nothing, which means every single car, truck, and ambulance trying to get from one side to the other has exactly one option: wait for a ferry. And Norway's engineers have come up with a solution so strange that when you first hear it described, it genuinely sounds physically impossible. They want to build a highway that floats, submerged 30 meters underwater, suspended in open water, like a bridge turned upside down and dropped into the fjord itself. Cars driving through it exactly like a normal tunnel, while massive cruise ships pass silently overhead without ever knowing it. Is there? And if that sounds like science fiction, understand this. Norway has already spent 20 years and hundreds of millions of dollars proving the physics actually works. The only question left unanswered is exactly how you physically build it. Norway's main coastal highway, a single route meant to connect the entire western coastline of the country, currently has to stop 7 separate times along its length simply to load vehicles onto ferries, because the geography of this coastline makes a continuous road nearly impossible using conventional construction. And in winter, when storms roll through, those ferries get canceled, stranding people who suddenly cannot reach hospitals, cannot get their children to school, cannot keep businesses running on schedule. And that single recurring failure, ferries that simply stop running exactly when people need them most, has become one of Norway's most persistent infrastructure problems. To understand the scale of what Norway is dealing with, consider this. The country has 1,190 separate fjords carved into its western coastline, meaning in large sections of the country there is genuinely more water than land. And the Sognefjord specifically, the deepest and most dramatic of them all, plunges to depths greater than most mountains on Earth actually rise above sea level, a body of water so deep and so wide that conventional engineering solutions simply run out of options. A cancelled ferry crossing does not just mean an inconvenient wait. It typically forces drivers into a detour lasting 3 additional hours around the fjord. And for an ambulance carrying a critical patient, that detour can be the difference between life and death. A reality that has shaped how seriously Norwegian engineers and politicians treat this problem. At its widest points, some of these fjord crossings would require a suspension bridge spanning 3 full kilometers. Yet the longest suspension bridge ever successfully built anywhere in the world today measures only about 2 kilometers, meaning a conventional bridge across Norway's widest fjords is not simply expensive, it is currently beyond the physical limits of bridge engineering entirely. Faced with 3 impossible options, Norway chose the one that had never been built anywhere before rather than accept defeat. And according to Chief Engineer Ariana Minaretti, one of the lead figures behind this project, the floating tunnel concept is genuinely the only solution that actually works for crossings. This deep and this wide, a conclusion reached only after years of ruling out every conventional alternative one by one. Financially, Norway calculated that its 7 remaining ferry crossings collectively cost the country billions of dollars every single year in lost time, delayed freight shipments, and failed or delayed emergency response, meaning that even an extraordinarily expensive floating tunnel program could ultimately pay for itself simply by eliminating those recurring annual losses. As part of Norway's broader E39 coastal highway upgrade, engineers identified 4 distinct methods for crossing different fjords along the route. Conventional bridges where geography allows them, standard tunnels where depth permits, floating pontoon bridges resting directly on the water's surface for certain crossings, and finally, for the deepest and widest fjords where nothing else works, the floating submerged tunnel, technology that, as of today, does not yet physically exist anywhere in the world. The basic concept itself is almost deceptively simple to describe. 2 massive concrete tubes suspended 30 meters below the surface of the fjord, held in place by floating pontoons anchored to the surface above and heavy cables anchoring the structure to the fjord floor below, a tunnel kato, permanently in tension between something pulling it up and something pulling it down. Yet turning that simple concept into an actual buildable structure has proven to be one of the most complex engineering challenges Norway has ever attempted. Left completely alone, a massive hollow concrete tube like this would naturally want to float straight up to the surface, so anchor cables running down to the fjord floor exist specifically to hold the entire structure fixed at exactly 30 meters depth. No more, no less. And the tunnel's walls themselves are engineered to a full meter of reinforced concrete thickness, separating a completely ordinary road surface on the inside from 3 full atmospheres of crushing fjord water pressure pressing in from the outside. According to engineers directly involved in the project, this floating tunnel Concept elegantly solves every constraint simultaneously because the crossing is too deep for a conventional tunnel and too wide for a conventional bridge. Yet because the tunnel floats safely below the draft depth of even the largest ships using the fjord, the surface of the water above remains completely undisturbed and fully navigable exactly as it always has been. Cruise ships regularly passing through these fjords can measure up to 70 meters tall from waterline to highest point, while the floating tunnel sits just 30 meters below the surface, meaning enormous vessels will glide directly above this submerged highway every single day without their crews or passengers ever realizing a road full of cars is passing silently beneath their hull. The planned crossing beneath the Sognefjord itself would require 3.7 kilometers of continuous floating concrete tubes suspended 30 meters underwater. A structure of this exact type that has genuinely never been built anywhere on the planet before. And because fresh air does not naturally circulate at 30 meters depth inside a sealed concrete tube, mechanical ventilation fans will need to run absolutely continuously inside the finished tunnel, never stopping, for as long as the structure remains in operation. Across Norway's broader E39 program, engineers are currently planning 4 separate floating tunnel crossings at 4 different fjords, each one facing a completely different combination of depth, current, and local geological conditions. And as of today, not a single one of them has actually been built yet. Every design remains firmly in the research and engineering phase. The actual construction method planned for these tunnels involves building enormous precast concrete sections entirely on land first, using completely conventional construction techniques, standard formwork, standard rebar placement, and standard concrete pouring, before transporting each finished section out to the fjord by barge, and only then beginning the genuinely unprecedented part of the process, submerging that section into open water at exactly the right depth and location. Each individual precast tunnel section is planned to measure roughly 200 meters long, built with a full meter of reinforced concrete wall thickness packed with dense steel. Reinforcement throughout. And while the actual manufacturing of these sections on land uses techniques the construction industry already knows extremely well, engineers are clear that the real, unprecedented engineering challenge only truly begins the moment each finished section actually touches the water of the fjord. A single waterproofing failure occurring at 30 meters depth would allow fjord water to completely flood an entire tunnel section within minutes, which is why engineers insist that literally every single centimeter of sealant and waterproof membrane across every joint must be verified, without exception, before any section is ever allowed to descend to its final operating depth. When the moment finally comes to launch a finished section into the water, engineers describe the process as functioning much like launching a ship, because a hollow, reinforced concrete tube this size genuinely floats on its own. And shore-based workers guide that massive structure into the fjord, using carefully controlled cable systems, gradually allowing the enormous vessel-like structure to settle into open water for the very first time. According to engineers who have studied this exact moment closely, that initial launch represents the single most dangerous point in the entire construction sequence, because a 200-meter concrete tube entering open water at even a slightly incorrect angle risks an uncontrolled and catastrophic sinking, meaning the engineering tolerance allowed during this specific maneuver is measured in millimeters rather than centimeters. Joining 2 separately submerged tunnel sections together at 30 meters depth under significant fjord water pressure demands that the resulting connection joint become completely watertight the instant it is formed. And this critical underwater work is carried out directly by professional divers, making the final physical connections by hand, though strict decompression. Safety limits sharply restrict exactly how long those divers can safely remain working at that depth during any single dive, meaning every single connection attempt has to be executed correctly, efficiently, and without unnecessary delay. Once a pair of tunnel sections have been successfully joined together underwater, pontoons are attached above the structure at the surface while heavy anchor cables are secured below, literally suspending the finished tunnel segment in the calculated tension described earlier, permanently hanging between opposing upward and downward forces. In the Sognefjord specifically, the anchor cables required to secure the tunnel structure to the fjord floor must extend an extraordinary 1,000 meters straight down, a depth far beyond what any human diver could safely reach, meaning remotely operated underwater. Vehicles, commonly known as ROVs, are required to make those critical deep anchor connections directly from the surface, controlled remotely by trained operators watching video feeds and instrument readings the entire time. These ROVs are effectively working on completely unmapped underwater terrain, because the floor of the Sognefjord at these extreme depths has genuinely never been physically worked on by human. Engineering before this project began. Fjords are not still, silent bodies of water either. They carry real, persistent underwater currents, meaning the finished floating tunnel structure will constantly sit inside continuously moving water. And the anchor cable system, securing it to the fjord floor, must therefore resist that steady directional force permanently, indefinitely, for as long as the structure remains standing. During severe Norwegian winter storms, waves in these fjords can reach heights of 4 full meters, and all of that violent wave energy strikes directly against the surface pontoons, holding the tunnel system in position. Yet engineers are adamant that the submerged tunnel itself, 30 meters below all of that surface chaos, simply cannot be allowed to physically shift more than 10 centimeters under even the worst storm conditions imaginable. A specification described by engineers directly involved in the project as effectively a guaranteed 100-year performance standard for the entire structure. While ordinary ferries regularly fail to operate and ordinary coastal roads regularly close during severe winter weather, engineers explain that once fully built, this floating tunnel would close for essentially nothing, because it physically sits well below the reach of surface storms and dangerous weather conditions entirely. For safety, the design calls for 2 separate parallel tunnel tubes connected to each other by cross passages, spaced roughly every 250 meters along the entire length, meaning that if any kind of incident occurs inside one tube, drivers can immediately evacuate directly into the adjacent tube through a nearby connecting passage, which then leads upward through pressurized emergency shafts rising all the way back to the surface. In the specific case of a fire breaking out 30 meters underwater inside the tunnel, engineered suppression systems are designed to activate within just 30 seconds of detection, paired with a smoke extraction system capable of moving 200 cubic meters of air every single second to keep evacuation routes clear and breathable. While this fully floating tunnel concept remains firmly in the design and research phase, a genuinely enormous and directly related project along the same E39 coastal corridor is already under active construction right now, a project known as Rogfast, where tunnel boring machines are currently cutting directly through solid rock 392 meters below sea level. And remarkably, many of the exact same specialized engineers and construction crews currently working on Rogfast are expected to eventually move directly onto building the floating tunnels once that phase of the broader program finally begins. Rogfast itself includes an underwater roundabout positioned 250 meters below sea level, widely described as the deepest road junction ever constructed anywhere on Earth, built entirely inside solid mountain rock running directly beneath an active fjord. Completing Rogfast has already required removing roughly 10 million cubics meters of solid rock using conventional drill and blast mining techniques carried out 392 meters underground, with the entire project scheduled for full completion by 2033, ultimately delivering 27 kilometers of dual carriageway highway running through solid rock, 392 meters beneath the fjord above it, an extraordinary undertaking that is not a future proposal, but genuinely active construction happening at this very moment. Progress on Rogfast currently averages roughly 4 meters of finished tunnel bored through solid rock every single day, and engineers openly acknowledge that the still unbuilt floating tunnel project, once construction genuinely begins, will likely require an even longer overall construction timeline than Rogfast itself, given how much of its engineering remains fundamentally unprecedented. Right now, in 2025, Rogfast continues under active construction, while the floating tunnel concept remains deep in ongoing engineering research, and Norwegian officials have repeatedly emphasized a simple point. These fjords have physically existed for roughly 10,000 years already, and Norway is entirely willing to remain patient a little longer if that is what proper engineering requires to get this right. Engineers studying the wave forces expected to strike the tunnel's surface pontoons calculate that those pontoons will absorb wave impacts roughly 10 times every single minute around the clock, meaning that across a full projected 100-year operational lifespan, the structure would ultimately need to withstand somewhere in the neighborhood of 5 billion individual wave impacts, an entirely unprecedented cumulative fatigue load with no comparable existing structure anywhere in the world to reference for guidance. To understand exactly how that repeated wave loading would behave over such an enormous timescale, Norwegian researchers have already spent roughly 15 years conducting detailed wave tank testing, building physical scale models, and running extensive computer simulations, and officials are clear that full-scale construction genuinely has not yet started for one simple reason: the underlying research itself is still not considered complete. Norway does experience occasional earthquakes, and while genuinely strong seismic events remain relatively rare across the country, engineers have specified that the finished floating tunnel structure must be able to survive a magnitude 5 earthquake without developing any water leaks whatsoever, a serious design requirement given how catastrophic even a minor breach would become at 30 meters underwater pressure. At least 12 different countries around the world are reportedly monitoring Norway's ongoing floating tunnel research closely, including the United States, China, and Italy, each nation quietly waiting to see whether Norway can actually prove this unprecedented engineering concept works at full scale before attempting anything similar themselves. According to engineers directly involved, Norway is genuinely designing an entire category of infrastructure without any prior precedent anywhere in the world to reference. No existing completed reference project, no historical failure data to learn painful lessons from, and effectively no safety net beyond their own research, meaning the engineering team is quite literally writing the technical textbook for this technology as they go, one calculation at a time. Norway's dramatic fjord landscape has historically been the very source of the country's regional isolation, cutting off communities from each other for centuries, and the floating tunnel program represents an explicit, deliberate attempt to finally end that isolation completely, delivering the first genuinely ferry-free, weather-independent coastal route in the country's entire history. Today, an ambulance responding to an emergency on the wrong side of an active ferry crossing can face a wait of up to 3 hours before reaching a hospital, a devastating delay. The floating tunnel program is specifically designed to eliminate entirely once construction is finished. The current road journey between Bergen and Stavanger, two of Norway's most significant western cities, takes approximately 5.5 hours today, largely due to multiple mandatory ferry crossings along the route. And once the completed E39 upgrade, including its floating tunnel crossings, opens, officials project that same journey will shrink down to roughly 2 hours and 45 minutes, cutting the total travel time nearly in half. Many fjordside communities across Norway remain genuinely economically isolated today, specifically because of unreliable ferry-dependent transport links. And officials argue that once finished, the floating tunnel network will allow those same isolated communities to reach broader European markets within just a matter of hours, rather than enduring the unpredictable delays ferries currently impose. A shift officials believe justifies the full $40 billion investment purely through the resulting economic activity alone. University students living in fjord-side communities today frequently need to take as many as 3 separate ferry crossings just to reach classes in Bergen. And once the E39 floating tunnel network opens, that same journey is expected to become a single continuous road trip requiring no ferries whatsoever. Norway's fjords already rank among Scandinavia's most visited natural attractions, yet visitor access currently remains heavily dependent on ferry schedules and seasonal availability, and officials expect that once the floating tunnel crossings open, visitors will simply be able to drive directly into these regions on their own schedule rather than planning entire trips around limited ferry timetables. Norwegian officials have been explicit that this technology is not being developed purely for domestic use, because places like Chile, New Zealand, Canada, and Scotland all face remarkably similar deep water crossing challenges, and are reportedly watching Norway's progress closely, hoping to eventually adapt the same floating tunnel technology to their own geography. Italy's Lake Como and Lake Maggiore present very similar deep water crossing challenges, where no bridge or conventional tunnel currently exists, and industry observers widely expect that if Norway can successfully prove this floating tunnel concept works at full scale, Italy will likely become one of the very first countries to attempt building a similar crossing of its own. China's Three Gorges region reportedly faces comparable deep water crossing challenges, and Chinese engineering teams are reported to be studying Norway's ongoing floating tunnel research directly, widely expected to follow Norway's lead once the underlying technology has been fully proven and validated at scale. Certain locks across Scotland reportedly reach depths exceeding 200 meters, presenting exactly the kind of crossing challenge floating tunnel technology was, specifically designed to solve, and reports suggest Scotland already has as many as 10 potential crossing sites identified and ready for consideration once the underlying technology has been fully proven. Norway has reportedly been actively patenting nearly every individual engineering solution developed throughout this extensive research process, including specific anchor cable systems, pontoon design details, and underwater joint connection methods, positioning the country to eventually license this entire body of technology internationally once other nations begin pursuing similar floating tunnel crossings of their own. In total, Norway has already invested roughly 20 years of dedicated research and hundreds of millions of dollars developing a technology that, as of today, still does not physically exist anywhere in completed form, driven by the simple recognition that ferries alone are simply no longer an adequate long-term transportation solution for a modern coastal economy. Remarkably, the very first patent describing a submerged floating tunnel concept was actually filed in Britain all the way back in 1919, meaning Norway's current active engineering program in 2020 represents roughly 100 years, separating the moment this idea was first patented and the moment it may finally become a genuine, physically built reality. South Korea reportedly has its own floating tunnel proposal under consideration. China has ongoing feasibility studies underway, and Italy already has specific candidate crossing locations identified. Yet by most expert assessments, Norway currently leads this entire global race by roughly a full decade of accumulated research and engineering progress. What this ambitious floating tunnel program ultimately aims to permanently replace is an ordinary, unremarkable scene repeated every single day across Norway's western coastline. An ordinary ferry loaded with cars, crossing an ordinary fjord in the middle of an ordinary Norwegian winter storm, delayed, occasionally cancelled, and quietly costing the country enormous amounts of time and money year after year after year. As of right now, in 2025, Rogfast remains under continuous active construction while dedicated floating tunnel research continues in parallel. Parliament has already approved substantial preliminary funding, and full construction level funding approval is widely expected to be the next major milestone in the overall program. Among all 4 planned crossings, the Sognefjord crossing, measuring just 1.2 kilometers in total length, is widely expected to become the world's very first completed floating tunnel, not because it represents the single largest or most technically demanding crossing planned, but simply because its more modest scale makes it the most practical location to prove the underlying technology actually works in real-world conditions before attempting the far larger and more technically demanding Sognefjord crossing. Right now, in engineering offices across Oslo, teams of engineers are actively designing an entirely new category of infrastructure that has genuinely never existed before anywhere in the world, working without established textbook answers and without any previous large-scale failure to study and learn painful lessons from. Current projections suggest formal parliamentary approval could arrive sometime in the late 2020s, with the very first completed floating tunnel crossing potentially opening sometime around 2035. While the far larger and more technically demanding Sognefjord crossing specifically may not reach full completion until sometime in the 2040s. Once actually completed and opened to traffic, engineers emphasize that the everyday driving experience inside these floating tunnels will feel remarkably ordinary. 2 standard traffic lanes, standard tunnel lighting, completely normal driving conditions, despite the fact that drivers will be traveling 30 meters directly underwater the entire time. 1 local ferry captain, reflecting on the eventual ferry crossing his own vessel currently operates, one that this exact floating tunnel project is specifically designed to replace, noted that by the time the tunnel officially opens, he expects to have already retired from his position, though he expressed genuine pride knowing his own children will likely be among the very first generation of local drivers to actually use the finished tunnel once it opens to regular traffic. Once again, engineers widely expect the relatively modest Sognefjord crossing to become the world's very first completed floating tunnel, even though it is far from the single largest engineering challenge among the 4 crossings currently planned under this broader program. Specialized construction crews and engineering teams are reportedly already being trained and prepared well ahead of formal government approval, specifically so that once parliamentary funding finally clears, an experienced, fully prepared workforce will be ready to begin serious construction work immediately, rather than losing additional years assembling and training a new team from scratch. The Sognefjord specifically experiences brutal winter conditions, violent storms, and seasonal ice, yet engineers insist the completed floating tunnel is specifically designed to continue operating safely and reliably straight through all of it every single day, for a guaranteed projected operational lifespan of at least 100 years. To put the eventual scale of this transformation into perspective, a journey along Norway's western coastline that currently takes roughly 21 hours today, largely due to multiple mandatory ferry crossings, is projected to shrink down to approximately 11 hours once the completed E39 floating tunnel network fully opens, while the 7 separate ferry crossings currently required along that same route are expected to be reduced down to 0 once every planned floating tunnel crossing has been fully completed and open to regular traffic. As one Norwegian engineer close to the project put it, Norway is not simply building a tunnel in the conventional sense. The fjords themselves have quietly existed for roughly 10,000 years, waiting patiently for exactly this kind of solution, and engineers were ultimately left with little choice but to invent an entirely new category of infrastructure, specifically to finally cross them properly. Standing above the Sognefjord itself, the numbers involved remain genuinely staggering. 1,300 meters of total depth beneath the surface, with the planned tunnel itself floating at a controlled depth of just 30 meters, meaning an almost unbelievable 1,270 meters of completely open water will sit directly beneath the finished structure, held in place entirely by a carefully balanced combination of surface pontoons pulling upward and deep sea anchor cables pulling downward. Families living along this exact stretch of Norwegian coastline currently cross this same fjord by ferry every single day as a routine, unremarkable part of ordinary life. A ferry hat regularly cancels outright during severe winter storms, forcing a lengthy 3-hour detour around the fjord for anyone unlucky enough to need to cross during exactly the wrong weather window. And it is precisely that daily, unremarkable hardship that the completed floating tunnel program is ultimately designed to permanently eliminate. Roughly a full century after a British engineer first patented the basic concept of a submerged floating tunnel back in 1919, Norway is now finally attempting to actually build one in physical reality, driven ultimately by a simple, deeply practical motivation. The country has quite simply grown tired of losing entire winters to canceled ferries, delayed ambulances, and communities left stranded on the wrong side of water that has separated them for 10,000 years. With a projected total cost of $47 billion and a category of structure that has genuinely never been built anywhere in the world before, Norway's floating tunnel program spans 4 separate fjord crossings and stands to fundamentally reshape how coastal infrastructure gets built worldwide. And at this point, for Norway and for every other country, now quietly watching from the sidelines, the real question is no longer whether this technology will eventually work. Engineers are already confident that it will. The only remaining question is simply when the first car finally drives through it,